Okay, let's go and get started today. We're going to do a little bit more stuff with the trig functions that we did last time. And this time we're going to do something a little bit different with them rather than making things move the way we did before. And today we're going to do some drawing of objects with those vectors like that. All right, so let's go ahead and take a look at what we're going to do today. So here's what we're going to do. Quick review. Radians are a way of measuring angles based on a circle with radius 1. So if we have a circle with a radius of 1, and let me get a little prop. Domino's cup. So here's a circle, radius of 1 unit. Then the distance all the way around that circle would be 2 times pi, or 6.282 whatever. And so the idea is that you measure the angle by how far you went around the circle. So if you go halfway around the circle, you will have gone pi units if that's a radius of 1. So this was pi. That's 180 degrees. Pi over 2. So if I walk pi over 2 units, that's 90 degrees. Pi over 180 would be 1 degree. Pi over 18 would be 10 degrees, and so forth. So it's just measuring how far the distance is that we walked around the outside, and that is the angle. So if I go 2 pi, I'm back to angle 0 again. If I go 4 pi, I'm back to angle 0. If I go negative pi over 2, I'm down here at kind of that 270 degree area down here. So you can notice you can walk in the positive direction, or you can walk in the negative direction. And this is backwards from, I should be over here from your point of view. So this would be like 0 degrees over here. That would be pi over 2, or 90. That would be pi, would be 180, and so forth. So the idea there is radians are this mathematically natural way to measure angles because they're based on pi, which is a universal constant that is the same no matter where you are in the universe, unlike degrees, which are arbitrary human measurement. Okay. So again, we end up with this. 0 is over here to the right. Pi over 2 is directly up, and you can see the other fractions of pi going around here. So any of these are representative of that, and we can convert that using the simple concept of, well, halfway around the circle is pi. So pi, that's 180 degrees is equal to that. So with that ratio, pi divided by 180, we know how big a degree is in radians, and we can do 180 divided by pi, the inverse of that, to know how many degrees there are in a radian. All right. Now, sine and cosine, quick review of those. As we walk around that circle, not only are we covering a distance that we're using to represent the angle, but we're also now a certain distance away from the horizontal axis and a distance away from the vertical axis. The distance from the horizontal, meaning the up and down, is sine. The distance away from the vertical, meaning how far to the left or right we are, is cosine. And you'll notice that as we walk around, we get farther away from the x-axis and closer to the y-axis, and then we start getting farther from the y again and closer to the x. And you can kind of see that charted out here. So the trig functions are really just a way. Sine, how far up and down? Easy way to remember that. Sine up and down. And cosine is left and right. Okay, so here's what we want to do today with that information is, let's say we want to draw this spaceship shape, and we want to draw that with like a polygon. So we're going to kind of connect these dots with these lines, and you might say, well, this is the center of the ship right here, and you might think, well, let's say this is point 1, that's point 2, that's point 3, that's point 4. So we have 4 points that we want to connect the dots with. They're all around that center because we're going to want to move this ship around. We want to base them on that center point. So one way we could think about that ship is that polygon with those 4 points. And one way we could think about those 4 points as each having their own x and y position, like we show here. So P1x, P1y, P2x, P2y, P3x, P3y, P4x, P4y. And if we could calculate those based on how far away from the ship x and y we are, we can then move this whole thing around to different places on the screen. Now, we can think of those as offsets then from this point. So for example, point 1, its x and y, we could think of that as, well, here's the ship's x and y, we just add 30 pixels to that, and that gets us over to here. And for the y, we just leave it the same. The y isn't any different. We're in the same line as this. And then P2, well, that's going to be to the left. So it's going to be x minus something. Here I did x minus 15, since that's about half the distance over to here. And then y minus 10, because we're about 10 units up this way. And then point 3 is essentially x minus 10, 0.3y. In this case is the same. In other words, we're along the same y value here. And then 0.4 is the same distance back that 0.2 was, so minus 15, but this time it's plus 10 to move us down 10. So in other words, minus 15 on x plus 10 on y gets us to that. Now that would work great as long as we wanted the ship to always be facing to the right like that. But in a game, we might want that to like rotate. We might want the spaceship to move to different angles as we're playing the game. In other words, as we're playing the game, let's say if this was the ship, we might want it to be facing different directions at different times. Or maybe if we had like a turret, we wanted it to rotate and point in different directions. Or we had a spaceship, we want to be able to face it in a direction and thrust it and move in different directions. We're going to want to not have it always facing this way. That seems weird to have it moving around and being always sideways like that. So we need something to be able to make this rotate. Now the concept of what we're going to do is similar to what we did here, but we can't just use offsets like we did. We need to have it so that when the ship is at, right now the ship is, we can think of it as kind of at angle 0. It's facing directly to the right along angle 0 as seen back here. So it's facing directly to the right along angle 0 or 360. But what we're going to want to do is make it so that point that could be at a different angle. So rather than being 30 pixels directly to the right, like we have there, so let's say this is let me do it backwards since we're on the screen now. So this is the center of the ship. Rather than 30 pixels directly to the right, we might want it to be rotated up, so it's 30 pixels at 45 degrees. Or maybe it's straight up and down. That pen's a little bit too big. Let me move it backwards. So it might be 30 degrees at 90 degrees, or pi over 2. 30 degrees at pi. And we might want to have it be anywhere around that 360 degrees when we rotate it. So if we want that to rotate, we can't use offsets like we did here. So the offsets would need to be different depending on what angle we're at. So offsets alone aren't going to work. So what I want to do is think about the points as being some distance away from that center of the ship at some angle offset. So for example here, this P1 is still 30 pixels away even if I'm facing this direction, just like it was 30 pixels away back here. Still 30 pixels away. But notice it's at some angle. So we can imagine a triangle being formed right here, over this way, up there. And that's going to tell us how far away it is in x and how far away it is in y. But this is hypotenuse of this is still going to be 30. So we're going to want to solve for this dx and dy given this angle and that hypotenuse. Now that's something we've done before. So in other words, we're going to think of, here's the ship's center right here. There's P1 over here. We're going to think of it as, and let me take this off. This is confusing with some of this down here. Hold on one second. That stuff shouldn't be there. So in other words, here are my 4 points. Right now I'm focusing just on P1. So P1 is 30 pixels away at plus 0 degrees from the direction the angle of the ship is facing. So here's the angle of the ship. Right now it's at 0 degrees. Now if the ship angle was like 10, we would have 10 plus 0, and it would be 30 pixels away at 10 degrees, which would put it up here. Now let's think of the other points that way. So let's think of this one over here. What's this one? This one is going to be the length of this hypotenuse, which is, if we look at that, that's probably about half of what this is, maybe a little more than half of that. So we'll say 20. So this is 20 pixels away at 120 degrees. And here's this annoying thing down here again, which I don't know why that's left there. All right, so this one's 20 degrees at a positive 120 degrees from where we started. So in other words, this is the nose of the ship. This is kind of back and to the left. So plus 120 degrees. So in other words, if I were to measure this angle right here, that's 120 degrees, and this is about 20 pixels long. Now, what about the one right here? So this is less than 20 pixels, obviously, and it's at an angle of, based on the nose of the ship, all the way around to 180. So P3 is going to be a distance of about 10 at an angle of ship angle plus 180. And again, I got to delete this. Now, what about P4? Well, that's also going to be a distance of 20, but now rather than 120, the easy way to do this is just on the other side, so let's just do minus 120 for that. Okay, so now we have our 4 points. P1 is 30 pixels at 0 degrees, P2 is 20 pixels at 120 degrees, P3, and let me go and fill in the, here, I'm going to pause this and fill in those other things, and then we'll come back to this in just a second, so hold on. Okay, so I just made a couple changes to this, so let's shift back to it. Okay, so where we had finished up was adding this P4, which was 20 pixels at minus 120 degrees. In other words, this angle back here. So in other words, we're making all of the points relative to this center one at some number of pixels away from it and some number of degrees away from its heading. In this case, the heading, the ship is facing directly to the right. That's 0. So this is this along the same heading, so plus 0 degrees. This one is 20 pixels long at 120 degrees. This one is 10 pixels long at 180 degrees. This one is 20 pixels long at minus 120 degrees. So now that we've done all that, the next step here is to figure out what the displacements are. So kind of like we did the offsets before, but now we're going to do it at the angle. So we're going to use sine and cosine to figure out the angles, and then multiply that by the distance away that thing is. So in other words, this one's a 30 degrees at ship angle. This one would be, or not 30 degrees, 30 pixels at ship angle. This one is 20 pixels at ship angle plus 120. This one is 10 pixels away at ship angle plus 180. So we're just going to calculate the x and y's using sine and cosine. And again, sine will give us the vertical, the change in y. In other words, how far away in y do I need to be from my ship x and ship y? And cosine, or ship y, cosine will give me how far in the x away I am from that. All right, so let's look at the code for that. So here's what the math would look like. So here are all of the positions that we talked about, and here is the corresponding code. So notice P1 was 30 pixels away, so there's the 30, times cosine of the angle. Again, x is cosine, y is sine, and here is 30 away at the sine of the angle. And you might notice like this is a minus here. Why is that negative? That's negative because in Pygame our coordinate system is inverted. So we're going to use negative wherever we're using sine, positive wherever you're using cosine. And we're going to do that for each of these. So 30 pixels away at angle plus 0, 30 pixels away, angle plus 0 for P1. P2, both of those are 20 pixels away at angle plus, I have a 130 here, that should be 120 to match what we had on the chart over here. Let me fix that real quick. 120, 120, 120, 120. All right. So there's our 120. And then P3 is 10 pixels away at angle, the ship angle plus 180. So all directly behind the direction the ship is going, 10 pixels away. And then P4, 120 degrees minus 120 degrees from the angle the ship is facing and 20 pixels away. So that's going to give me those 4 points. And then all we have to do is connect the dots to make a polygon. So there are the dots connected. And now we've drawn that ship. And now we can change this angle variable, and the ship will point at different directions when it gets drawn. And if I move the x and y around, I can move around where it is on the screen and have it change the direction all at the same time. All right, a couple things to consider before we write the actual code. The math module uses radians. So back here in this example code, notice I just use angle. I did not convert to radians anywhere in here. We're going to need to do that in our code. The other thing is the y values had to be subtracted rather than added, and that's because of the inverted y-axis in Pygame. And the other thing to note about this method is we can really make any shape we want using something like this. If I wanted to make like a star that spun around, or I wanted to make a thing that looked like an arrow with an arrowhead and a body and have that point at things on the screen, we could do that. If I wanted to make it where the shape was like a triangle or a hexagon or something irregular, like the game Asteroids, where you have some jaggedy thing and it spins around, we could do all of that with this code that we have here. So let's go ahead and write the actual code for this. And the way that code is going to work is we're going to make a function that draws the spaceship. And we're going to pass to that function the x, the y, and the angle we want it to be drawn at. And then we're going to have the code in here that draws it, and we're going to use the pygame.draw.polygon. Now this is not complete code. Obviously the dots are where we need to fill in other stuff. So what we're going to do right now is we're going to switch over to Pygame, and I'm going to throw some code together for this. So hold on one second while I switch to a Python window. Okay, so here we are. So I'm going to put a comment on the top and say, this is the rotating ship example. Now we know we're going to do this in Pygame, so import Pygame. We also know that we're going to need to do some trigonometry functions, sine, cosine, radians, degrees. So I'm going to import math to have access to those. And now here, def draw ship. This is where we're going to fill in that function. And here we're going to have x, y, angle. Now we're going to come back to this code in a second. I'm going to put pass there. And what pass is really a null statement placeholder. So that allows this to have an indented function body without me filling that in yet. And I'm going to put a little comment in here to tell myself that to fill this in a second. So and one of the things I'll do when I'm working on larger projects is if there's something that comes to mind that I know needs to be done, but I don't want to do it right then, I want to do some other stuff first, I will add a comment like this that has this to-do thing written in here. And then what I can do later on in my program as I'm developing it, I can search for those to-dos, and then I can knock them off the list. So rather than having to switch to like a word processor or take out a piece of paper and write down my to-do list of things that I need to remember to do before I'm done with the program, I can just add a comment, and when I do that, I can delete that comment out of there. Or in some cases, you can change it to done. And in some cases, depending on what I do, is I'll put change that to a done and put the date that it was done, and maybe my initials if it's something that's a shared project. This can help us later to know that we need to go back and fill something in. This is not completed. There's something I need to do here. Okay, but let's get the rest of the stuff working first. So let's go ahead and fill in the rest of our code here. So we need pygame .init. Obviously, if we're going to use Pygame, we also need to create the display surface. So I'll just call it ds pygame dot and set mode. And I'm repeating all this over and over again so you guys get used to thinking of that and familiar with it. All right, so we've set the mode. Now, I'm going to go ahead and make some variables for our spaceship. So I'm going to say ship x. And let me start it out in the middle of the screen. So 400, so ship y equal 300. And let's give it an angle. So ship angle, maybe we would call it heading or whatever, but I'm going to start it at 0, so it should be facing directly to the right. So the idea here is that we have that, and maybe at some point we want to have this thing move around. So I'll say ship speed. I'll set it at 0 for now. Maybe we'll change that, maybe we won't. We'll worry about that in a little bit. But the main thing that I want to do right now is set up the kind of framework for the program, and then we're going to go in and fill in some more the draw ship code. So the first thing I'm going to do is let's make our game loop. So while true, enter the game loop. We're going to obviously get some keyboard input and maybe some other inputs. Let's do pygame.event.pump. We need to do that. We need to get the key state. So we'll make a keys variable, set it equal to pygame.key.get pressed. So something we've done a lot. And now let's just make it so we can get out of the loop. So if keys subscript pygame.k underscore escape. So if that's true, then we break out of the game loop. Now, at the bottom of the game loop, we're going to have to eventually do an update screen. So pygame.display.update. And then after the loop, we need to close a window. So pygame.display.quit. Okay, so let's go ahead and run this right now, make sure everything works right, even though we don't have it drawing the ship yet. So what I like to do is kind of get one thing at a time working. We could probably do more. We've done this a lot, so we know what's going to happen. Let's call this rotating ship, but let's save it somewhere else here. I don't want to put it in my downloads directly. Let me put it on my desktop. Okay, and the program runs. Let me move that where you can see it. And there's the window, and I hit escape and the window closes. So no errors, that worked out fine. So we're all good with that. So now let's go back and write a little more of this code. So let's go ahead and work on the draw ship function. So I'm going to go ahead and in here, I'm going to call that function down here, draw ship, and I'm going to pass to it the ship X and ship Y and ship angle. So ship X, ship Y, ship angle. So that's what I'm passing to that function. And now I think we're ready to write the code, some of the code for this function. So let's go back up to our to-do. So right now, for example, here's another hint when you're working on stuff. One of the things you might do here is just temporarily put like pygame dot or pygame.draw.circle, I mean. And here, when we go to draw this circle onto the display surface, let's just make it a color of white. So, and we might say like X, Y, 10, 0. Now this is kind of like stand-in graphics. In other words, this isn't the full thing, but if we run this, you'll see there's our circle that is representing the ship. So we know that function's being called. We know it's putting the thing at the right place. And so now we're ready to actually write the real code. So I'm going to take this out. We know that this is getting called. We know it has an X and a Y, but we want to actually have this draw the polygon at the correct angle. So in order to do that, the main concept of what we need to do here is what we did back in the slides. So in other words, let's go back and look at that one more time, just for a second. I'm going to have to go back. So this is what we want. So point 1. And in fact, I'm going to make things easier. Well, I'll type it out. But essentially, point 1x is, this is going to be x because it's inside of our function. We don't have to use ship x there because we passed it in under the name x. And then this is going to be 30 pixels times whatever cosine returns of the angle of the ship. So let's go ahead and go back to the screen and start writing that code. So here, I'm going to take out my to-do, and I'm going to say p1x equal, and in this case, remember we had 30, x plus 30 times math.cosine. Remember, we need math.cosine because of how we imported that. And then in here, we need something that's in radians. Right now, we have degrees, so we're going to do math.radians of angle. Now, one of the things to save me some typing rather than having to do math.radians every time, I'm actually going to make another variable here, right here. And I'm going to call this angle rad. And that means when I put this in here, I can just put angle rad, and I'm going to go ahead and calculate this and do math.radians of angle. So that way I only have to really convert it once, and then I can use it throughout the rest of the parts of this code. So in other words, we have 30 pixels, math.cosine, and this is cosine because that's an x, and we're adding that to x to move over that number of things. So that's going to be what we want. Now for y, p1y, this is going to be the same. So I'm just going to cut and paste, but this should be minus because of the inverted nature of y. And this needs to be sine. All right, so pretty simple. So we have 0.1. So now to do 0.2, let's go and take this pass off here. We don't need that anymore. So now to do 0.2, I'm just going to copy these two and make a couple changes. So 0.2 is going to be x plus, we said this was 20. And now this one was not at angle rad. This was angle rad plus a certain number of degrees. And in this case, it was 120. Now, if I try to do that, that's going to create a problem. And the problem that's going to create is that this is in radians, this is not. So we need to convert this, math.radians, 120. Or we could have converted that up there if we wanted to. I'm just going to do that. And I guess by trying to save time up here, I don't think that really helps. So I'm actually going to take this back out and just going to do it long-handed because we have to add all those offsets. And so otherwise we'd have part of it doing it one way, part of it doing it another way. So it's just for clarity's sake. And the other thing I'm going to do is to make it clear, I'm going to put a +0 here to show that all of these are really kind of the same. Oops. That way all these will be symmetric. They'll all kind of work in the same way. So this needs to be +120. This one needs to be +120. So there's my 0.2. Now 0.3, we'll just copy these, paste them again, change this to 0.3, change this to 10, change this to 180. And then 0.4, that's 20, but this is minus 120. Or we could have done plus 240, I guess, but either way, I think it's easier to think of it this way. All right, so now we have our 4 points. Now we just need to connect the dot with those. So to connect the dots, we basically just need to draw a polygon. And one of the things that I want to do is I want to draw this a little bit differently than we had it. Well, let's just do the polygon to start with here. So here, let's do pygame.draw.polygon. And the way that works, the surface we're drawing on is a display surface. The color, I'll go ahead and leave it as white for now. And then the next thing we need now is, if you remember, it's a list of points. And the way we make a list is a square bracket. And we're going to need to put in all those points. So the first point in the list is going to be P1. So P1x, P1y. There's my first point. The second point in the list is P2. To save a little time, I'm just going to copy these and change the numbers. So 0.2, so 2, 2. The next one is 0.3, 3, 3. The last one is 0.4. So there's my point list. And then the final thing we need here is the width of that. So in our case, I'm going to go ahead and just make the width, oops. Oop, where am I? Okay, there I am. So I need to make the width, I'm going to make it 2 pixels wide. And that's it for my polygon function. All right, so let's go ahead and run this and see what shows up on the screen. And we screwed something up. All right, it's giving me a warning about using integers instead of floats, but there's my shape. And you notice it's not quite the shape that we want. It doesn't quite have that inflection on the back. It looks more like just a triangle. So we want to either bring that in or bring these back to make a more swept wing appearance. And so we might just want to change the angle, or we might want to change that distance. I think the angle looks a little square, so let's bring that back a little bit. So in order to change this shape, notice that what we can do, let me move this out of the way. Oops. What we can do is now we can change how that thing looks just by changing those angles or those offsets. In other words, if I want the wings to be a little longer, instead of 20 here, I could do like 25. Or if I want them a little bit swept back farther, I could change this to a different angle, like 130, 130. So let's see what that one looks like. All right, that looks a little better. We've got a little bit swept. Maybe I want that to be maybe a little more, or maybe let's make this a little less far back. So that one, rather than 10, let's make that one something like 5, or maybe like 8. And let's make these ones a little longer. Let's make this 25. All right, let's see what that looks like. All right, so there we go. We've got something that looks a little more like what we wanted. Maybe they're a little bit too far back. We'll leave it like that for now. I think that looks okay. Or let's make maybe make the nose out in front a little bit more. So rather than 30 here, we can say like 40. But notice how easy it is to change these things, what that shape looks like, by just messing around with those distance away those points are. That looks a little more like what I was going after. Now, we don't have a way to make it rotate right now, so let's add that. So we already have the code in here to have it observe the angle. So if I were to change the angle variable and say, well, let's draw it instead of at angle 0, let's draw it at 45. So now it should be facing the nose rather than directly to the right. It should be kind of up and to the right. Let's see if that actually works. And let's add some code so we can change the angle. So there it is at a different angle. All right, so to change that angle, all I'm going to do is add a couple keys to this. So to add some keys, I'm going to say if keys, let's make it rotate with A and D. So if pygame dot k underscore A. So if they press the A key, then I'm going to say ship angle. Let's see, that's rotating counterclockwise, so we want to do plus equal 1. And if we do KD, then ship angle minus equal 1. Now, there's one other thing I probably ought to add, and that is, notice I'm not clearing the screen anywhere in here, so it's going to sit over the top of itself. So let's add a clear screen here. So ds.fill. Oop, caps lock got pressed. So ds.fill 0, 0, 0. Okay. Let's run it and see what we get. So there it is. Now we can rotate that ship to different angles. And one last thing that we can do here is I might, if we want to change the shape of that or make it filled in with a certain color, we can. It kind of has a retro look to it right now, so I think I'll leave that. But you notice we can draw that at any angle that we want to here and have it rotate any way that we want it to. Now, I'm going to go ahead and make it solid and filled in, and then I'm going to add one other feature to this in a second to make it draw it a little bit more interestingly. And right now the ship can't move. We don't have any thrusters or anything. We're going to look at how to do something like that coming up. But notice that this works. I don't know why it's entertaining for me to do this. I've written code like this a lot over the years, but I still find it looks cool. All right, so let's exit out of that. And let me add, make the ship solid. And let me, here's the cool thing about doing it this way with a function is now if I want to change the way that ship looks, I can just change this code. So one of the things that I'm going to do is I'm going to take this and let's look at that ship again real quick. So there's the ship, and in looking at that ship on the screen, so right here, notice that I'm going to draw it as, rather than one big polygon of one solid color, I'm going to draw it as two triangles. So in other words, point 1, point 2, and point 3 is going to be one polygon, and the other one's going to be 1, 4, and 3, or 1, 3, and 4. So let me divide that up into two polygons here to start with. So I'm going to take this line, and I'm going to duplicate it. And the first one, I'm going to take it out, and I said I want that to be just point 1, 2, and 3. So I'm going to take point 4 out of that list. And then the other one is going to be 1, 3, and 4. So I'm going to take this one out of the list. And let's look at what that looks like. So now we have that line down the middle. Notice it still works the same way. But now I'm going to make those two sides different colors. So to make those different colors, I'm going to make this one first off filled in, and this one also filled in. And then what I'm going to do is I'm going to change the color. So I'm going to make this one kind of a purplish color, so red. Let's make this 0, 255. Let's make this a little more blue than red, so let's put a 200 there. And let's make this one kind of the opposite. Let's make this one, the green still 0. But let's make this one more red than blue, so let's leave 255 there. Let's put 200 there, and let's see what that looks like. Okay, the one on the bottom is a little bit maybe too bright, a little bit too hot pink, but notice that we now have this cool ship. So let me make this this one a little more blue too. So let's do this one as 200. Let's do 150, 200, and see what that looks like. All right, that looks a little better. We've got this kind of two-tone purple thing going on for our ship that has this illusion of kind of like a shape to it. And you'll notice if you wanted to, you could actually have not just that, but we could also still draw that polygonal line over the top of that to make an outline. So now we have the ship with an outline to have a little bit different effect. Maybe it looks a little bit like shields or something. But you'll notice that we can play around with how that draws and use those points however we want. Now, there's one other change I'm going to make to this. I'm going to go ahead and take this out for now. So it's just this. But one of the things that I want to do is, what if I want a thruster to appear? So in other words, if I press the space bar, then I want this to have like a thruster that comes out behind that spaceship when it draws it. So notice that that could be done the same way. So where should the thruster come out? It should come out directly out of the back of the ship. And it should probably be kind of random, so we want it to kind of like wiggle around, like spray out the back. So I'm going to add some code to be able to draw that thruster in here as well. So let me go ahead and do that. But before I do that, I'm going to do a save as on this. And I'm going to call this rotate ship with thruster. All right, so to add the thruster, I'm going to make another variable here. I'm going to call that, instead of P1, I'm going to call it thrust.1, so T1x. And I'm going to make a T1y. And notice that with this one, what I'm going to do is I'm still going to do x plus, and I'm still going to do y minus, because it's still, the thrust is still coming out of that ship. But the way I'm going to draw this is I need to make a point that is somewhere out behind the ship, kind of like P3 was. And in fact, I'm going to go ahead and copy the code for P3 here, at least this part of it. And I'm going to use that as a basis for thinking about where we want that thruster line to be. So in this case, it probably needs to be more than 8 pixels. So let's just say this is like, I don't know, let's do 20 for right now. And then with this still, we want that to be 180. And so this code here is going to be the same, except that's a minus, and this is going to be a sine. Oops. Sine. And to make this more clear, we might add some comments in here. Let's call these ship points. Let's call this and what I'm going to do with this thrust point that I generated is I'm going to go ahead and draw a line from the center of the ship, so pygame.draw.line, onto the display surface. Let's make the color of that red. And when we go to draw this line, remember the line has a starting position and ending position. So the starting position is just going to be the ship x and y, so x, comma, y. And the ending position is going to be that T1x, so T1x, T1y. And the only time I want to draw that line is when the ship is actually thrusting. So what I'm going to do up here is I'm going to add another variable that says thrusting equal false. So in other words, this is a third or a fourth argument to our function, or a parameter to pass to our function, and this equal false, that gives it a default value of false. In other words, if I don't pass it, it'll assume it's not thrusting. If I do pass it, then I want to include this code here. So what I'm going to do is I'm going to put all this inside of an if statement. I say if thrusting, which sounds a little questionable, but we're talking about spaceships. And then I'm going to go ahead and move that in underneath that. So the only time I calculate that point and the only time I draw that line is when the ship is thrusting. Now down here where I call that, I'm going to add a variable that is called ship thrusting. I'll start it out as false. And then down here, if they press the space bar, then I'm going to set ship thrusting equal to true. Else, if they're not pressing the space bar, they want ship thrusting to be false. So now when I press the space bar and we call this draw ship, we're going to pass that in, ship. We should see that thruster appear. Now it's going to look kind of stupid right now because it's just a line. So it looks more like a little weird tongue thing sticking out of the back. And it really isn't very long, so let's actually make that a little longer. Again, cool thing about using a function, we can just change this up here and say, well, 20 wasn't long enough, let's make this like 40. And when we draw the line, let's give it a width to make it a little wider, let's say 2. So there's my thruster. Now it doesn't look like a thruster, it just looks like a frog sticking a tongue out. So what I'd like to have is that to be a little more animated. So how can I make that thing animate and jump around? Well, one of the ways is to add some randomness. So rather than picking the same distance every time and the same offset every time like we are here, what I'm going to do is come up here, import random, and down here in my code, I want to make this thing kind of have some randomness here. So here I'm going to say, let me put a variable here and say length equal random dot rand int, and let's make this maybe between like 25 and 45. That's my length. And let's make the angle. To be clear, let's call this the thrust length. Let's call this the thrust angle. And let's do another random number here. So random.randint. And on this one, let's make it not always 180, but let's make it like something like a 170 to 190. And we can play with that a little bit. So now down here, when I go to draw this, this is just going to be the thrust angle. Oops, what happened? Thrust angle. And then this over here that was 40, that's going to be our thrust length. Okay, so all we did is we take out that distance away that point was and make that have some randomness to it, and then take the angle, and rather than having it always be directly at the back, it'll be have some randomness with that too. And we could also add a little bit of randomness to the color. Yeah, let's do that. Let's make this between 200 and 255. And let's add a little bit of green in here too and make this 0 to, I don't know, let's do 150 and see what that looks like. So adding a little bit of green in, we'll add some yellows and some oranges, but without any blues. All right, let's see what we get. Okay, so there's my thruster. Now, there's a problem. Notice that problem is we're having it always face the side. We need it to still track the angle. So to do that, where I just did thrust angle plus 180, actually we already had this at 180, so we actually put that in the wrong place. That needed to be here. And this still needs to be the ship angle right there. So this needs to be angle plus that. Now let's take a look. All right, so there's the thruster. It still doesn't look like a very good thrust. It's kind of a little piddly line, but it is wiggling around. And maybe we want a little bit wider spread on it. 170 to 190 doesn't seem that great, so let's do 160 to, what's up, is 200. Maybe a little bit better. But it still looks kind of spindly. It still doesn't look really like a thruster. So one of the things we say is, well, maybe we just need more kind of an impact from that. And so one of the things is, well, look, let's start off by making it a little bit longer. So the thrust length, let's make this go from 40 to 60. And let's make it, when we draw that line, let's make this, rather than 2, let's make that 3. See what that looks like. Okay, a little bit better, but it still looks more like a weird wagging tail than it does like an actual thruster. We want more of like a cone to come out of there. So what I'm going to do is I'm going to make a whole bunch of these. So I'm going to put this inside of a loop. Now, this is something that's a new kind of loop. So for I in range, and let's make 10 of these. And what the for loop does, we'll talk about a little bit later. We're going to talk about that next week. But essentially what it does in this case is we're just saying, go through this range of values. It starts at 0, that goes up to, but not including 10, which is going to go through 10 total times. Go through that and keep track of which one we're on by using this variable I. So I is going to be 0 the first time through this indented code. The next time through the indented code, I is going to be 1. The next time 2. The next time 3. We could do this with a while loop, but this is a little more convenient because we don't have to create the variable and then have the loop, and then at the end of the, or have the while loop look at the variable, and at the end of the loop increment it. This is a little more convenient. We just say, hey, for every I in the range of 10 items, 0 through 9, do this thing. So we're going to get over and over again 10 random lines, and let's take a look at what that looks like. So there's my ship, and there's my thrust cone, much better. And what's cool about this is we can change the variables of that for what that thruster looks like. If I want a wider spread or a bigger cone or more randomness or different colors, I could change that around. But notice that it follows the ship, the direction of the ship, because we base it off the angle of the ship and use sine and cosine to figure out how far to make that. We could also add more or less of those lines. So if we wanted to have, instead of 10, like 50 of them, and we wanted our length to go from 40 to 90, now we have a much bigger kind of spread of stuff coming out of the back of that ship. And in fact, we could go crazy with this if we wanted to and say, hey, make the angle 90 to and I'm going to make this a little more clean. So 180 minus 90, 180 plus 90, that's the spread. And now let's go ahead and make this like the random length. I will leave that alone for now. And now it looks like it's like a, I don't know, a weird magic thing, like a torch, like the Olympic torch. Ta-da! But notice that that works and it tracks whatever angle we go to. Now that plus or minus 90 is probably pretty stupid. So let's change that. Like, let's make it 60. So this is a thrust cone of 60. Oops, one of them's 50. It's going to be asymmetric. That's still too much. Let's do 40. 40. It's a little, still a little bit wider than I'd like it. We'll do 30. 30. Okay, so we'll go ahead and stop there for today. And notice we could still add this white line around the outside. We had that code still in there. Changes kind of the aesthetic of it a little bit. Or if we wanted to, we could make that line some other color. I think it looks better without it. All right, so that is how we can use trigonometry, the trigonometric functions, to draw vector things. We right now don't know how to get this thing to thrust and actually apply that as a force. That's just a little more trigonometry. It's actually pretty easy. There's not much code we would need to do to add that. But right now we know how to move and know how to get it to be rendered at facing any direction. And so next time we will look at some other uses of trig to actually get this thing to thrust and fly like an actual rocket ship does. And it turns out that the trig we've already learned is enough. Just like today, we just use sine and cosine to draw this rather than move it. Next class, we're going to add in the ability to add forces to things and have that thrust and move around on the screen with a force applied. Okay, so make sure to work on your lab. And we're going to come back to that kind of for loop thing that we looked at with up here. And we're going to talk about sequences of things. And we're going to move towards, like, for example, this is kind of a good start towards something that looks like sort of like an asteroids game. But one of the things that we would need to have that game be complete is we need a way to have this thing fire bullets out of here. And we might want to have more than one bullet on the screen. And we might want to have more than one asteroid thing on the screen at a time. So we're going to have to figure out how could I add something like that to have a lot of different things being kept track of. And we're going to look at a method. We're going to look at what are called sequences, which lists are one of those, which allow us to add things and take things out. And a cool thing is this for loop we just saw is going to allow us to iterate through those things. So we're going to be able to do something like saying for every bullet in our list of bullets, we're going to then move them and draw them, see if they collided with anything. And eventually we're going to have these really complex, rich games that can have a whole lot of things moving around and doing things at one time. And it really doesn't take much more code that we have here. But before we do that, we're going to spend a little more time with some trigonometry, applying forces to things to make this thing thrust and to make things move in a more natural way. But other than that, let's go back to the presentation for just a second here. And let's finish this up. Okay, so we connected the dots, we wrote the code, it looked like that. And that's it for today. Make sure to work on assignment 6 and see if you can get that working. Also, I'm a little disappointed. I know that a lot of you have not been watching these videos. And you signed up to be to a programming degree or an art degree. And if you're an artist, this coding that we're doing in here can be really powerful and useful if you're going to do animations. There are programming languages that underlie tools like Maya, like production animation tools that are used in the industry. And the best animators, the ones that get good jobs, are the ones that can write a little bit of code to do things, to help automate things. For example, you watch a feature film and there are things going on in that, like blades of grass moving, or trees that are each individually different that are in a forest. For the most part, you don't have an artist that's hand drawing every one of 10,000 tree models that are going into that forest. They're writing code that modifies and makes those trees and makes them different from each other. Or the way that the things are animated is not with hand moving each piece of grass at each frame and then making a bunch of keyframes for it. Somebody wrote some code that is actually driving that. So if you're an artist, the coding will help automate things. It'll help you be a power kind of developer rather than a newbie. And so learning a little bit of programming is good for you. And if you're on the programming side, this stuff is understanding how to use the trigonometric functions, how to make stuff happen in the code. This is a starting point for doing really cool stuff, really magical things. And when you watch or play a kind of commercial game, whether that's something like simple, like a more casual game, or it's something like a AAA title, the stuff that we're learning in here is going to be really powerful and useful throughout your career. So if you're not interested in this stuff and you're not watching the videos and you're not understanding it, then you're going to have a difficult time making it through this class. You're going to have a difficult time making it through the degree. So really, you should be watching this stuff. You should be writing the code. You should be playing with it. It's actually a lot of fun. I actually could sit here for hours adding things to the spaceship and adding shields to it and making it thrust and move around the screen and making it shoot bullets and making it blow things up and making it so that when it gets hit by things and its health goes to 0 and it dies, it breaks into little pieces and they all drift off. All of that stuff is a whole lot of fun. And the more of the programming techniques you learn, the more of a little bit of math, like the trig functions that we learned and are now using and applying, the more of that you learn, the richer your kind of capability set is. The ability to do magical things increases and increases to the point where you'll get to the point, if you know enough stuff, that you can imagine anything you want that game to do, you can put together some code that does that. So it's like taking ideas out of your head, putting them in the machine, and then watching it do something. And that's really, to me anyway, that's like the closest thing that we have as humans to being able to do magic. And that's true whether it's writing code that goes in a game, or writing code that does something else, or writing code that goes in something like one of these little microprocessors on one of these little sensor boards, or designing this thing to wirelessly communicate and send data and know its position and its movement. All of that stuff is really magical, but you got to spend a little bit of effort learning it. And we're going to continue with that next class. So if you haven't been watching these, you're probably not watching this one, so I'm probably talking to the people I don't need to. But anyway, those of you who have watched these, good job. It'll pay off in remarkable multiplicative dividends throughout your academic career and your career as a programmer. So good job for you. If you haven't been watching them, go back and start watching them, because this is good stuff. And you're going to come to a point in this class when you're taking the final, or the next class after this, or graphics that you'll take next year, where you're going to wish you had paid attention more, because you're going to be lost on how to do some things. All right, that's it.